these wonderful opportunities to all of us. So I wish this webinar a good success. Thank you very much. Jai Hind.
Thank you, sir, for your kind words. And definitely our local center and nearby area will try to achieve your aims on your chairmanship so that mining engineering division also flourish in all parts of India as well as abroad. With this, I will request the chairman of IE Durgapur Local Center, Engineer Shafiqul Islam, to give his introductory address regarding the webinar. Engineer Shafiqul Islam, please.
Am I audible?
Yes, sir.
Yes, yes.
Thank you, Mr. Bilal. And we are very sorry for the inconvenience. Due to some technical problems, it was not possible to join from Durgapur Local Center in time. So let us, very good evening to all of you. Respected President of IEI, Dr. H.O. Thakariji, respected Professor Nitai Chandra De, Chairman Mining Engineering Division Board, IEI, respected Dr. G. Ranganath, Chairman, CARTE, IEI, respected panelist, Dr. Arindam Bishwas, Associate Professor and HOD Mining Engineering and Computer Science, Kazi Nazrul University, and Mr. Ali Murtuza Sheikh, Deputy Manager Mining, Coal India Limited, Dr. Joydeep Dotto, Assistant Professor, Department of Computer Science, Kazi Nazrul University, Mr. Ranodip Bhattacharjee, Deputy Manager, Coal India, and Mr. M.K. Bishwal, immediate past Honorary Secretary of Durgapur Local Center and Senior Technical Officer, CMERI Durgapur, and Director Technical and his team members of IEI Headquarters, and all the participants from different sectors and friends, heartiest welcome to you all again on today's technical webinar on very pertinent topic, computer application in mining, organized by IEI Durgapur Local Center under the aegis of Mining Engineering Division. We are very pleasant that many participants have joined, more than 100 participants have joined in this seminar. And with the valuable address from the very eminent personalities and with resourceful presentation from our respective panelists, we hope everyone will be benefited with this, looking forward to a colorful event filled with lots of learnings. And thank you all. And at the last, I will request our Honorary Secretary, Mr. Manoj Majumdar, to continue the proceedings. Thank you, sir.
Thank you, Engineer Shafiqul Islam.
Hello, sir.
Sir, Professor Manoj. Hello.
Hello, Manoj Majumdar, please.
Manoj Majumdar's audio is not working, so Mr. Bhattacharya, kindly continue until he joins.
Sir, you are not audible, I think.
Then moderator can take care.
Hello.
Hello.
Myself, Manoj Majumdar, Honorary Secretary, Durgapur Local Center, II. As our chairman, Mr. Engineer Shafiqul Islam, told something, and I also give NC Day, Professor NC Day, Chairman MNDB, and Chairman CARTE, Dr. G. Ranganath, have already told. I introduce the moderators. Mr. Ranodip Bhattacharjee, Deputy Manager, Coal India Limited. Mr. Manoj Kumar Biswal, immediate past Honorary Secretary, Durgapur Local Center. Senior Technical Officer, CSIR, CMERI, Durgapur. Now I told Ranodip Bhattacharjee to tell something about this evening's webinar. Ranadi Bhattacharya, please.
Thank you, sir. Thank you all. So I've already discussed about the importance of mining industry, and regarding the topic, it has been already discussed. So I think without wasting much more time, we are directly go to our first speaker. In this regard, I request Professor N.C. De. Sir, Professor N.C. De is both professional work. He was engaged as a colliery manager in Coal India Limited, and thereafter he switched his job in teaching. He is the most experienced teacher in mining engineering at IIST Shibpur. So I request sir, please share share your experience and deliver your valuable words. I request participants to please listen to him. It will be very interactive and interesting session also. Thank you, sir. It's all yours.
Thank you very much, Ranadi. So before going to my actual sharing with PPTs, I would like to tell a few lines to accommodate my ideas with you very nicely. What is that? The thing is this, today I'll be giving you a little glimpse on a very new topics. Khas karke Ranganath ji. So it is the ergonomics application in mining through computer. So this is the fantastic, you see, the subject which, if I'm not wrong, it is hardly people would be getting a chance to listen on ergonomics, because it is hatke hai, it is little bit different. Sometimes you see we the engineers do not know much on it. So, but exclusively, this is the science which is, you see, the related with the physiology, and it would be you see, the very interesting to note and learn that how the physiological attributes and parameters can help to have our day-to-day performance indicator. As if a person is putting some drilling holes in mines, or drilling somewhere in someone in the rocky measures. Now you understand the rocky measures. So putting some drill holes. So how much drill hole he can put within 2 hours without having some fatigueness or without having some musculoskeletal disorders? Can we put them 2 hours continuously? Can we ask them? Or should we ask them 40 minutes at a stretch? Or after 40 minutes, how much rest to be given? Is it 10 minutes? Is it 20 minutes? Or is it 1 hour? You think that you don't have any answer. Can you answer me? I believe no. Because you will be looking at their face. Are ye fatigue ho gaya kya? Ye thak gaya kya? Likewise. But you don't have any instrument. You don't have any science to understand. So this is what the very essence of ergonomics, by which every bit of working, not only you are sitting in a chair in your house, or you are doing some your IT related job with the help of computer, or you are driving a car, or you are driving one Volvo bus, or you are putting up some drilling holes in mines, or you are operating some loading machines in some industries. Everywhere ergonomics do come in. If I ask that one Volvo operator or one person who is operating one dumper under some environmental parameters, what is the workload, physiological workload? Nobody has given a thought. But what do you mean by workload? We do not have any idea. So based on this, keeping this thing as backdrop, I'll be you're discussing little bit of things. It is very few, because it is not possible to speak all these things within half an hour. But I'll be trying to share my ideas with you. Okay. So I am sharing my screen of PPT with you. So this is my, you see the, can you see it now?
Sir, it is.
And
This
make
is-
it full screen.
Yes, sir, we can see.
Yeah, this is the lecture on computer-based application of ergonomic concepts in mining. Okay, and your overall table of content today's program within 30 to 40 minutes is the general concept of ergonomics. I'll be telling, though I have shared already little of it. Need of ergonomics, reach of ergonomics, and ergonomic based provision on coal mine regulations, which has been newly published by Parliament or other legislative modes, and the ergonomic based application strategy, and overview on relevant computer-based postural applications. This is very important. Was REBA, RULA, these are the different computer-based applications, and work stress indicators and workload determination. That is also important. How we will be calculating the workload, and finally the benefits and recommendations. So you see that your physical ergonomics is a discipline which attempting to adapt the job. That is important because everybody, right from his birth to his learning, his schooling, then coming to college and going for your, you see the professional studies and all, is not fit to adapt any job. The job has to be made fit towards a person. What is our goal? Looking after the goal of having a good health. This is our base, that whatever you see the job you have to adapt or you have to fit with the workers of any age, that should create a good health, that should create a good ambience and safety, that should give a good comfort, and finally it gives a good amount of production or productivity so that the company is benefited. That is our baseline objective. And you see that ergonomics is considered to be a tool, effective tool, which can reduce the injury rate, which can reduce the stress, and thereby it can increase the availability of men and machine towards the production. So why availability? Because if it increases the injury rate, or if it increases the stress and strain while you are at work, then obviously next day you will be absent. You won't be coming regularly on your job. That's why if you take in mining khas karke, if you take your percentage of, you see the attendance, you'll be finding, if I'm not wrong, Murtaja Ali and others, they are in the directly associated, Ranodip also directly associated with coal industry, that I'm not telling wrong, that about 30 to 35% of absenteeism would be we get every day on an average 30 to 35%. So there must be some reason, but hardly we analyze it. That what is the reason of so much of huge percentage of absenteeism, khas karke in mining? Because today's topic is in computer application in mining, so most of the your application-based example I'll be giving in mines. So next is Indian mining has been the area of concern for low availability of miners, coupled with the increased rate of injury. It creates the muscle fatigue. It creates the different posture related stress, and it gives some other biomechanical stress related problems that is known as the musculoskeletal disorder problems, and which can affect the productivity directly and directly the availability. That means it increases the absenteeism. So this is the call of the day. We have to think that how come we can motivate the workers, motivate the supervisors towards our production productivity, to enjoy the work, and at the same time to bring about all the comfort level, and finally then their available percentage would be much high, and their absenteeism percentage will be much reduced. Next is, you see that the coal mining regulation,
Sir,
the new one,
sir,
the 2017.
Sir, slide is not moving, sir. Kindly.
So not visible.
Slide is
Slide is
visible, but it
not
is
moving.
stuck at first slide, sir.
No?
No, slides are not moving, sir.
It's not moving, sir.
Only the first one.
Yeah,
Yes, sir.
it's stuck in the first one itself. But everyone is enjoying your lecturer, but slides are not moving.
It is my bad luck. No?
It is in the first slide itself.
Sir, make it full screen, F5. Please press F5.
Control F5.
No, only F5. Or you can make it full screen by selecting the button at the bottom.
I have done that.
Okay, then I think then it is. Yeah. Now it is moving. Now it is moving. Okay, fine. Fine. It is okay.
It's moving.
Yes, sir.
Yeah.
Yes.
Right.
Yes.
Oh, thanks God. Thanks God. Acha, see, now the coal mine regulation 2017, it is the latest one in India that we cannot change it because it is the legislative. Nobody in India, none, even our Prime Minister cannot change it. So this coal mine regulation 2017 is our Gita for the mining activities. All the mining people will endorse this thing to me, with me and other. And specifically for ergonomics, this time, the first time ever, the ergonomics word, ergonomics application, and ergonomics importance has been given in coal mine regulation 126 and coal mine regulation 215 out in this book, CMR. So that's what that indicates, that this topic has got a tremendous importance right out there. And now what I was talking of about the workload of any system, for any driller, for any operator, for any driver, even a valve operator, even while we drive car. So these are the parameters to indicate our workload. This is known as scale of heaviness. How do you find it? That it is based on there are a lot of other parameters, but these two very basic and important parameters I will be addressing here. One is the pulse rate, which is in BPM, beats per minute. Another is the energy expenditure in kilocalorie per minute. These 5 different work type or work class we have in India: light, moderate, heavy, very heavy, and unduly heavy. And if we go by this parameter, and if we get a person is 120 BPM during what, so we would be telling average, that would be obvious for 100 for 1 hour, for 2 hour, the average heartbeat is about 120 BPM. So it is under this heavy category. So this job with respect to that person will be very heavy. And if it continued for more than 130, then it is very heavy. If it is more than 150, then it is unduly heavy. So for every category, we have to find out the work schedule. What would be the work bouts and what would be the respective your rest. Because every work, even in the during study in your house, in your home, if we study for 1.5 hours, we take 10 minutes rest. Thoda chai pee liya, thoda pani pee liya, kuch, that is in the form of rest. So for every work, for every bit of operation in any industry, we need to have the job operation or in some spell. So that is between spell 1, spell 2, spell 3, like this. So combination of all spell means 8 hours job, one shift job. I believe I am very clear to you. So likewise, every spell of job, we ought to calculate or ought to measure this heart rate, as well as we have to convert this heart rate into energy expenditure. Okay, there are some formula of calculate deducting this HR to energy expenditure. So if energy expenditure comes in within 4, so job is moderate. And if it is you're more than 6 but within 8, so job is very heavy. So you have to be very cautious out there, that what is the nature of job and vis-a-vis what is the workload. Workload like this, the light to unduly heavy, and based on that, what is our work scheduling. I can assure you, you'd be unable to show me that almost all industries in India, be it automobile, be it boiler, be it any mechanical, any chemical industries, have gone for this study category wise of person. I am assuring you that you won't be finding that category wise all people's workload determination. Why? और उसका साथ साथ what would be the work bouts, BOUTS, what would be the work bouts. Work bouts means spell 1 and spell 2 in between rest, spell 2 and spell 3 in between rest. What? We do not know. हम लोग क्या करते हैं, चाहिए 15 मिनट रेस्ट कर लो, but that may not be sufficient for him or her, or that may be excess. There might be the 8 minutes of rest is kafi tha, but we are giving them 15 minutes. Why? So these are the things are noted, and we must go for this study. You see the reach of ergonomics now. You see the reach of ergonomics ensures the human needs for safe and efficient working, which can be made to have the good design or good work system. And in order to do this, we have to design the appliances. So you see, the ergonomics also will take care of the design of the machine, the appliances, or other apparatus, and the technical system, that the software side, hardware side, how much software is there, how much is hardware part is there, and what is the percentage exactly, and who are the persons you're dealing with these technical systems. Are they really trained? So training has also been one part in the coal mine regulation 216, that given that about the your training part. And now the task. What are the tasks they're exactly doing? Are they putting holes? Are they putting some roof support in mines? Are they pushing some trams inside the mine? Are they operating conveyors? Like this, for every job operation, we are to design this work system in such a way that it must improve the human safety, it must improve the health, it must give the proper comfort, and finally the performance towards the industries. If any science cannot give rise a good performance, good efficiency, no science can be applicable towards any industry. Our engineering science must be oriented towards the performance, enhancer. Unless we are performance, we cannot increase our the production and quality of the material, we cannot increase. Then what is the use of this science? What is the use of this engineering technique? So this is utmost important. Though we must have to work sometimes in mines, particularly in awkward postures and positions. We have to do with some heavy or very heavy workload. We ought to have some inadequate rest period, because we have not done the work rest bouts, even in mines. And assuming the prolonged posture in sitting and standing also, it gives some sort of musculoskeletal disorders. And if there is vibration, for example, drilling, you are putting some holes, drilling, so it will be giving some vibration right out your whole body. And out due to this vibration, you may feel some sort of sickness. You may feel some type of, you see, the musculoskeletal disorder, some sort of stress, some sort of strain right out there. Achha. Now you see the next one. Can you see now? Is it visible?
Yes, sir, visible. Go ahead.
Nice. So you see the ergonomics application, you're pointing towards the posture and biomechanics. Then assessment of bad posture during mining operation, you can take it for any other operation. I am giving an example, mining here. I am uttering mining because the today's topic is computer application in mining. But it is true for all, even in chemical, it is in agricultural, and in mechanical, in electrical, anywhere, in civil based. So assessment of bad posture during mining machinery operation can be done through this 4 technique. REBA, which is the rapid entire body assessment. RULA, which is the rapid upper limb assessment. There's OKRA, which is the occupational repetitive assessment. And there is the back compression force measurement, which can be found out through some other WAS technique, work evaluation assessment method, WAS. Seat and cabin design, you can see the design of the seat. Likewise, what would be your reach, your left reach, right reach, and what would be your sitting posture before say you're on an office table or somewhere else. The design of the seat and cabin according to the operator's anthropometry. Anthropometry means what? Anthropometry means what is your height, what is your body surface area, which is known as the body surface area. There has been some Dubois equation to measure the body surface area. There is some body mass index, that your weight divided by height square, weight in kg, height in your meter square, meter. So weight divided by kg by meter square will be giving you the body mass index. So all this information are coming in towards the anthropometry. It has got huge connection with the design of seat and cabin. Otherwise, what would be there? There will be some caution zone, there will be some musculoskeletal disorders, there will be some, you see, the deviation from the CG, deviation from the CG. So if there is some deviation from the CG during sitting, during standing, or during operating of any machines, so it will give you some musculoskeletal disorders. We hardly give some notice on it. Even though while we sit in our home, we hardly give some backrest. You see, you test yourself, hardly you give your backrest. You see, you test now. in what position, in what posture you are just sitting. You see your backrest is not there. Either you are coming forward or your backrest position is very, you see the is very hard. It is not any cushioning effect there. You just test now. And some important other measurements are the buttock popliteal height, buttock knee height, sitting popliteal height, thigh clearance, as well as the waist depth and the zone of convenient reach, JCR. All these are the different ergonomical based parameters which ought to be kept here, so that your design of the seat and cabin very nicely done.
Slide the move question. Slide is not moving again, sir.
Again,
Yes, sir.
Yes, sir.
now
Yes, sir.
Sir, now fine.
see, while I coming up from the, you see the PPT showing it is coming. It is short one. जब शॉर्ट कर रहे हैं धारा, मैं जो फुल स्क्रीन में जा रहा हूँ यार, इसमें हो जाएगा ना? Can you see it?
It is visible, sir. No full screen, not records.
Not required. Okay, thank you. So let's see now the ergonomics application on the ruler posture, rapid upper limb posture. You see, it is based on the computer scoring, computer-based scoring. This sort of things you didn't come. You see how you see the CV is moving while it's sitting. Because the upper ruler, na, so based on sitting posture, this would be made. The wrist, the twisting, you're sitting, how much degree you are moving towards. So likewise, it measures the upper limb extremity, its postural stress. Because finally, you are to have some score like this, final score. So arm and wrist stress movement, neck, trunk, and leg movement. A scoring of 6 or more is considered to be risky. 6 or more. So likewise, so final score you ought to get it. If it comes to 6 or more, so then the posture is considered to be risky, and this posture is immediately to be rectified. Likewise, the REBA, rapid entire body assessment, deals with the entire body postural stress. OKRA with the repetitive mode. For example, drilling in mines, we are putting repetitive hole, one hole, second hole, third hole, fourth hole, fifth hole. So this OKRA, likewise, this another, it is not the OKRA, this is the ruler. So OKRA will come into place. So based on this, your computer-based software, this OKRA score is to be your calculated. And if it is coming beyond the risky zone, then we have to give some sort of, you see the recommendation. Now it is the WAS. You can see Overco walk analysis system. You can see this WAS technique. And WAS technique मैं तो आपको दिखा रहा हूँ क्या? This is the back, and this is the arm. This is the leg part, and this is the load with which you carry. You see that back part, it may be straight. Number 1 is straight. Number 2 is little bent. Number 2 is little bent. Number 3 is twisted, and number 4 is bent as well as twisted, both. Okay, and you see the 4 different posture we have, and whatever posture you make on the back side now, it will be coming within this. Now, and you see the now your arms are, you see the arms all be both arms in the downward position, one arm downward, one arm on the top, and 2 in the top positions. Okay, so 1, 2, 3 different postures with the arm. This is with the back. Now with the leg, you see the sitting position with this leg is a very normal one. And sitting on 2 straight legs is the 2, and sitting on 1 straight leg, 1 not, and the squatting. This is squatting like this, 4, and likewise the kneeling, walking like this. This is the leg part, and you see this is the ojan. आप कितना load ले रहे? It is within 10 kg and within 10 to 20 kg, and is more than 20 kg. Okay, so this is what the 4 different things: back, arm, leg, and load. Okay, and you see this is our, मैं आपको थोड़ा सा तो specimen दिखा रहा हूँ. See, this is our software, your manual, and you see here back, arm, leg, and load दिया हुआ है. अच्छा, assume like we assume what we are assuming that we are assuming that here one example already I have shown over here: 2, 3, 2, 1. Okay, 2, 3, 2, 1. Fine. आपको याद रखिए 2, 3, 2, 1. Fine. ये देखिए 2 यहाँ पर आएगा, 2 इसमें 3, 2, 3, 2 लोड में 2 and इसमें 1. 2, 3, 2, 1. So it is 2. 2 means what? Corrective actions required in near future. मतलब जो एक्शन में चल रहा है वो अभी ठीक है मोटा मोटी. अच्छा आप मान लीजिए मैं इसको क्या करता हूँ, इसको मैं ऐसा करता हूँ 3, 3, 3, 3, 2, 2, 3, 3, 2, 2. Fine. 3, 3, 2, 2. 3, 3, 2, 2. 3, 3, 2 और 2. ये देखिए इसमें भी 1. नो करेक्टिव एक्शन इज रिक्वायर्ड. ठीक है. अच्छा और एक तो हम लोग देख लेते हैं. ये देखिए फिर मान लीजिए एक तो बेंड में मैं देखता हूँ 2, 3, 4 मान लीजिए 2, 3, 4, 2. ठीक है 2, 3, 4, 2. देखिए 2, 3, 4 और 2. ये देखिए 2, 3, 4, 2. क्या आ रहा है? इट इज 4. तो मतलब करेक्टिव एक्शन इंप्रूवमेंट रिक्वायर्ड इमीडिएटली. So it gives the ergonomist an idea कि आपको फिलहाल immediately इसमें improvement चाहिए. Otherwise this person would not be able to continue his work in the same position from next day or next week or next month. Okay, so that is the indicative ideas the ergonomist will get. So likewise now the ergonomics application your मैंने क्या किया था ना, this is you see the one of the SDL machine or LSD machine. You see that in underground we are doing. This is my scholar. What we are doing? I see LSD operator in inch. What should be what we have got here, and this column is the reference. You see the seat height. We have our reference is 15 to 20, and we have got 12 here. Seat depth 16.9. We have got 16. Seat width more than 18. We have got 15. So obviously there is not comfort. There can never be comfort. Our reference range is more than 18, or it is 15. How come? Our backrest should be at least 12.2. ये ठीक है. अच्छा backrest width ये ठीक है. अच्छा रिवर में देखिए ये हमारा जोन ऑफ कन्वीनियंट रिसर्च में नहीं था. लाइकवाइज ये मशीन का है. आप ऑपरेटर से देखिए एटलीस्ट 26.8 होना चाहिए. इसका है 25.1. नॉट लेस देन 17 ये ठीक है. नॉट लेस देन 19.8 ये है. ये 4.2 रेफरेंस होना चाहिए. 4.5 नॉट लेस देन 23.5. Likewise we can examine every machine with the reference value and the operator. Here the machine operator with reference on both sides we can do. So based on that we can do for the every LHD operator load haul dumper. This is the load haul dumper. So and likewise there are different other machines, continuous miner, drill machine, your SDL machine, side discharge loader. All machines are there where we can check it through this BIFMA guidelines. These are the different very important guidelines which the ergonomists follow. And all these things are nowadays you're coming in the DGMS circular in 1/2018. Now comes the 215 CMR, coal mine regulation. You see the physical stress we have to estimate and workload determination we have to do through different analysis. What? The environmental analysis, thermal comfort factor analysis, and rest post regimen, which is this is known as work rest bouts or work bouts simply. And next come the environmental analysis. The thermal comfort factors like the PMB and PPD mode. These are the predicted mean vote and percentage of person dissatisfied. These are the models the ergonomists follow to find out the environmental analysis or environmental impact on the fatigueness of the workers. Based on that, you can see the PMB parameters. You see the SDL operator का हम लोग इतना निकाले थे, LSD operator के इतना निकाले थे, and UDM operator का it is the drill machine operator का इतना निकाले थे. And out there we got that SDL operators are facing maximum thermal stress in comparison to LSD and your universal drill machine operator. So there are some this PMB equation also. Now you see that there is some, you see the rest bouts. R means the resting time. Immediately you can calculate one resting time. How? You see, it is the Spitzer model. Spitzer model. What? It is based on some workload as is the rest pause regimen for a selective category of workers. E means the energy expenditure calculated in kilocalorie per minute. So you have to find out the kilocalorie based on the your beats per minute. I have shown you earlier the Astran scale. Based on the Astran scale, we will be finding out the we can just convert the HR means heart rate towards the energy expenditure. Energy expenditure by 4 minus 1 into 100 is the percentage of rest to be given in per hour term. पर आवर टाइम फॉर एग्जांपल देखिए आप इसको 5 कर दीजिए एनर्जी से 5 by 4 minus 1 कितना आ रहा 25% होगा 1.25 minus 1 is 0.25 so 25%. इसका मतलब 1 घंटा में 15 मिनट मेरा रेस्ट होना चाहिए पर आवर. So likewise the measurement of the heat stress WBGT weight bulb globe temperature and the threshold limit value for different depth of mines. Different depth में जाओगे आपका क्या होता है WBGT value change हो जाएगा. Because it is on the 0.7 natural weight bulb temperature and 0.3 your dry bulb temperature. This is known as the dry bulb temperature. Based on this, you see that NIOS, National Indication of Occupational Safety and Health. Okay, so and this is the American Conference of Governmental Industrial Hygiene. Based on that, you see that you have to select the whether you will be following this NIOS scale or whether you will be following the ACGI scale. So based on that, you see. Hardly in India we have got this sort of scale. हमारा इंडिया में इस तरह का ergonomics का अभी तक बढ़िया से for mining and some mechanical based industries में अभी तक इस तरह का स्टडी हुआ नहीं है. ठीक है ना. So that's why ये I am very sorry to say ये वाला हम लोग दिखा नहीं पा रहा. What should be our scale? We can show the American, we can show the NIOS, but we cannot show the Indians. Like see the calculation of relative cardiac cost and calculation of net cardiac cost. These are the stress indicators, is known as the work rate indices. So here I have shown some sort of, you see the calculation, little bit of arithmetic calculation. You see the this person, या हम लोग अंडरग्राउंड में इसको लिया था. इसमें देखिए MHRM लगा हुआ है. This is the sensor in on his chest. Okay, इसका नाम है MHRM, मोबाइल हार्ट रेट मॉनिटर. ये वाला लगा हुआ है, this HRM. Okay. तो मान लीजिए हमारा अगर रेस्टिंग हार्ट रेट, दिस HRMS मीन रेस्टिंग हार्ट रेट बिफोर द स्टार्ट ऑफ द जॉब. अब 58 इयर्स ओल्ड गर्ल आप काम कर रहा है तो उसको हमको 78 BPM हमको रेस्टिंग में मिला, मतलब बिफोर स्टार्ट ऑफ द जॉब. और जब वो काम शुरू किया तो उसको हम लोग मान लीजिए एवरी 5 मिनट्स हम उसका बीट लिया. आफ्टर एवरी 5 मिनट्स वी हैव नोटेड डाउन हिज बीट्स व्हिच इज 88 BPM, 92, 104 like this, 142 while he ends the job. Okay. So हम इसको क्या एवरेज करते हैं. Average will be coming 109.2. So NCC net cardiac cost will be that working heart rate average, that is 109.2 minus working heart rate is 78. So 78 करने से 31.2. and you see the NCC HRR will be heart rate max. Heart rate max क्या होता है 220 minus age. 220 minus age. 220 minus age is 58. So it is coming 162. Okay, 162 minus 78 is the heart rate here. So 162 minus 78 it is coming 84 BPM. So what is the relative cardiac cost? What is that means the stress indicator, that NCC by HRR into 100. So 31.2 divided by 84, this 84 into 100, so it is coming 37.2. So anything more than 30% is the strenuous. So here this particular gentleman, after doing some work, is under huge stress. So we have to reschedule his job, we have to redirect him, or we have to reschedule the working environment also. कभी हम लोग इसीलिए E-Tripper से थॉरो स्टडी हम लोग इसको वर्क शेड्यूल में जाएंगे और हम लोग इसको एनवायरमेंट को ठीक करेंगे, और एनवायरमेंट ठीक है तो वर्क शेड्यूल को चेंज करना है. समझ रहे हैं ना. और इन बिटवीन द रेस्ट आल्सो. So based on this we will be studying all this, and ergonomics only can give you this sort of idea that how this job can never be the strenuous to this gentleman, so that he can do the job with all comfort and he cannot develop the musculoskeletal disorders in his lifetime. Now comes, you see the RAS, another your stress indicator. It is known as the relative aerobic strain. The sample calculation I am showing here, that is a 50 years old person is working with working heart rate average is 130 BPM. It is the assumption, maybe 120, maybe 110, maybe 140. Then ventilation of oxygen while he is breathing at work is the formula, is this Ramanathan formula, minus 1.69 plus 0.02 into working heart rate average. Working heart rate average is 130 here. So we get is 0.91 liter. And VO2 max, मतलब while he is going the job in the top crest, उसमें HR max लेना पड़ता है. HR max is what? 220 minus age. Age is 50. So it is coming 1.71. So relative aerobic strain will be this divided by this, which is coming 53%. It is much higher. US accepted norm is only 33%. One third of 100. One third of 100. But here it is 53. In India, we don't have any norms. Okay. Whatever norms I have done in my study, so I have given this towards the ergonomics, that this is out my research. NCDA has given some relative aerobic strain percentage. You would be finding out in all my journal papers all over the world. I have got 76 number of journal papers produced throughout the world, and I have given this RAS in my particular study throughout the world to understand about what is the Indian context of RAS. I have studied and I have given it. Now this is my lab. This is my laboratory in IIST. This is my laboratory. I have got the treadmill. I have got the, you see the different your cardiovascular assessment apparatus, and you see that you have got the electromyograph for what we will be able to find out the fatigue prediction. We can do the muscle injury. We can do some sort of endurance related test. And you see that this is the TMT, and the TMT will be finding out the maximum V.O2, this one, VO2 max. For this, TMT is required. And this is done, both this is available in the Mind Safety and Ergonomics lab in ISTC pool. And what are the other scope of work? The triaxial hand arm related to vibration related analyzer, we can do it. And you can see that lecture. So I can give you this sort of this vibration is required, and based on this the information is required. What is the dose value? What are the weighted and unweighted root mean square value? What are the other threshold limit? Based on the different ISO and American Conference Governmental Institution of Hygiene. Based on this, we have to find out whether the dose value is correct and whether the other threshold limit value is correct. We will be able to compare. And now what are the benefits we have? The benefits due to on this computer-based application in ergonomics and mining, he will be giving you the improved comfort level. You can have your absenteeism low. You can put your posture good so that your awkward posture can be identified. Not only that, you can give some recommendation how your posture can be made beneficial towards the worker so that their musculoskeletal disorders will be delayed, or there will be no musculoskeletal disorders. And now the very important term, the delay in onset of fatigue. That the fatigue assessment technique, there is some, you see the Brouwer's technique we have, due to paucity of time, I am unable, I have not shown here how the fatigue assessment done by the Brouwer's technique. So there is some technique by which the fatigueness can be assessed. And it will obviously, if we can go for this will have some low injury rate. And by this, we can have some sort of, you see, the better occupational safety and health. And it will give you the very low compensation. The low compensation, why I am using here? Because almost in all the mines and mining company do give some sort of compensation towards the worker at the end of the year. Because there is some sort of injury. Because of this injury, हमको क्या है उसको compensation देना है. That compensation part would be very low or very insignificant if we can give rise all this sort of ergonomic application which we are discussing over here. So finally, it will be giving a very good. You see the your performance indicator, very good efficiency, that output per man shift, and EMS your earning per machine shift will be very high. So your mineral economy will be very developed, very good one, and very befitting. So finally, you will be reaching towards a healthy organization. So this is all about my today's lecture. Namaskar, Jai Hind.
Fantastic, lecturer, Chairman Ji. Chairman Ji.
हाँ बोलिए.
Very nice information shared with the audience and attendees.
Thank you very much. Thank you very much.
Both the chairmen of division and local centers should excuse me. I will take leave of you. I attend another program. So thank you, moderators.
Thank you very much.
Thank you, sir.
Thank you, sir. Thank you, Safir Lakan. Good night, all of you.
Thank you, sir. Thank you.
Good night.
Thank you, sir. Thank you.
Thank you.
Good night.
Yes, sir.
Thank you, sir. It was a very good, interesting topic to discuss. I hope all of our participants have enjoyed it very much. Our next speaker is Dr. Arindam Biswas, functioning as HOD, Head of the Department, Mining Engineering Division, Kazi Nazrul University. He is also an executive member of our Institute of Engineers Committee, Durgapur Local Center. May I request Professor Biswas to please share your valuable words, please.
Thank you, Ranadeep. My sincere regards to Chairman Engineer Shafiqul Islam, the Secretary Manush Sarkar sir, and my pranam to Professor De, IISc Shibpur, and my beloved colleagues, Dr. Datta is here, and my audience. Today we will discuss the applications of industrial IoT in the industrial IoT in mining industry, and the open research directions. What is the possible research direction, in which directions we can work? And basically, I am from the electronics background, being a faculty members of mining engineering department of Kazi Nazrul University. I have started working on IoT in mining industry, and we have received some fund to work to continue this work at Kazi Nazrul University, Asansol. So with this, I am trying to brief my ideas on industrial IoT, IIoT for mining industry, open research directions. My slide is visible, Ranadeep?
Sir, it is visible.
Visible.
Yes, sir, visible.
Hello, yes, it is visible.
Now, the industrial IIoT, industrial Internet of Things, that is named an IIoT, has potential to improve the production and business process, the extraction of valuable information from industrial processes. This is the important. That's why this is so important. And mining industry is rather traditional and somewhat slow to change due to the infrastructure limitations in communication, data management, storage, and exchange information. The most research effort so far applying IIoT in mining industry focuses on specific concerns such as ventilation monitoring, accident analysis, hazard accident fleet, and the personal management, trading dam monitoring, and the pre-alarm system, while an overall IIoT architecture suitable for the general conditions in the mining industry is still missing. So in my presentation, we analyze the current state of information technology in mining sector, identifies the major challenges of vertical fragmentation due to technological varieties in various systems and devices offered by different vendors, preventing interdisciplinary data distribution, and the exchange of information securely between the devices and systems. This is our main objective of this is the main objective of our research. Now, the IT in mining industry. In 1960s, the IT in mining industry first come in 1960s. Then the mini ERP compromising the presenting the pay of roles, listing of storage item, manpower control, and during 1970s, the designing of civil engineering, construction, line tracks, roads, etc. In 1980s, MIS, MPS, and TDS, and during 1990s, the application of GIS and GPS, that is mainly visualization, visualizing the technology that captures, stores, checks, and integrates the multiple display data and using the digital mapping. So this is the IT in mining industry. But nowadays, the application of machine learning for dog detection, IoT for hazard monitoring is introduced in mining industry. Now the comparative analysis of IIoT market. The research on IIoT if we plot from 2017 to 2025, if the projection on 2025, you just seeing that the market value is billion US dollars, and we expect IIoT market is expected to increase up to 110.6 billion USD by 2025. So this much important, this is much important of IIoT market will be, and presently this is exponentially increase the market of IIoT that has been published by our group in 2021. And there's a publication based on IoT and IIoT. You just notice here the different publication house is noted, that Nature's, IEEE, Elsevier, Springer, Wiley. These are publication houses noted, and you just number of publications year-wise plotted, and you just notice that in the exponential rising of documentation of IIoT. The rising of documentation this graph proves that the work on IIoT is going on rapidly. Now this is somewhere where we have written OT plus IT equals to IIoT. Now, at first we need to understand OT plus IT equals to IIoT. The industrial internet may also be considered as a convergence of information technology and the operational technology. The OT stands for operational technology, and IT is confirmed for information technology. So those both OT and IT converge, then the term IIoT comes out. The IIoT, what do you mean by IIoT? IIoT nothing but IIoT is a network of physical object or things. Okay, Internet of Things means nothing but a network of physical object of things embedded with electronic sensors, connectivity, and enable that network to achieve the greater value and service by exchanging data with the manufacturer, operator, and connected devices. This is nothing. This is the main functions of the IIoT. In IoT, at first we need to sense the data. We need to sense the physical objects. Suppose one accident happening within the underground or open cast minings. That the accident we have to sense that accident. Okay, we have to sense that accident. This is the physical things. We have to Internet of Things. So we have to sense that things by the sensors, and then that will be sent to the customers. So this is the Internet of Things. Currently, many IoT technologies are integrated into the consumer application, such as smart homes, connected cars, smart vehicles, and the industrial application of IoT or industrial IoT. However, they anticipated to have capacity to transform many industries, including manufacturing, oil, agriculture, gas industry, always. And now we can you can heard the name like that, industry, agricultural informatics. You can heard the term agricultural informatics. This is nothing but a application of IoT in agriculture. That the health informatics, application of IoT or machine learning in the health sector. So now those machine learning, IoT, those are the tools we can apply in the every industry based on the requirement. So this is the IoT. So we can conclude that IoT is nothing but a operation technology converts with the information technology. Now stages is mining life cycle. So okay, stage one is prospecting, then exploration, this development, then exploitation, and finally reclamation. Those are the stages is mining life cycle. So at first, we introduce the stages of mining life cycles to show the operations in the mining industry. So we are already told this is the operation technology plus IT. So that's why the operations in the mining industry is important. So overall sequence of activities in modern mining is often compared to the 5 stages in the life of a mining. The 5 stages are already showing here. Okay, so first stage is prospecting. So what do you mean prospecting? Search for ore. The prospecting methods, there is a two type of prospecting method. There is a maybe direct, maybe indirect, and located favorable loci. So prospecting, the first stage of the utilizing of minerals the mineral deposit is such ores or others valuable minerals that may be coal or maybe non-metallic, because mineral deposits may be located either at or below the surface of the earth. Both direct and indirect prospecting techniques are employed. And second is exploration. The second stage is exploration. You kindly show here, it is written that defining the extent or value of ore. Okay, the second stage in life of mine, the exploration determines as accurately as possible the size of the value of mineral deposit, utilizing techniques similar but more refined than those used in the processing. And number 3 stage is development. Development is nothing but opening of ore deposit for production. That depends on that this is the third stage, and that comprise on file environment impact statement, technology assessment, permit, transport system, construct facilities, exclave deposit, strip or strict search. Those are the part of development. So development, the work opening of mineral deposit for exploration is performed with it begins the actual mining of the deposit, now called the ore. Then the next stage is exploitation. The large scale production of ore. This is the exploitation. This is the fourth step of the stages of mining life cycle. The exploitation, the fourth stage of mining life, is associated with the actual recovery of minerals of the earth in quantity. Although the development of many continue, the emphasis is the production stage. On the production, usually only enough the development done before the exploration to ensure that production, once started, can continue uninterrupted throughout the life of the mine. This is the exploitation. And last stage is the reclamation. Reclamation, nothing but a removal of plants of building, reclamation of waste, and monitoring of discharges. Those stages, those are the 5 stages in mining life cycles. Now, IIoT standardization. The relevant industry reference architecture, which is proposed by the standard bodies. So here in my lecture, we discussed the 4 standardization of IIoT. Number 1 is industrial internet reference architecture. Number 2 is RAMI 4.0. Number 3 is O1M2M and Arrowhead framework. These 4 IIoT standardization we'll discuss throughout our lectures. The number 1 is industrial internet reference of architecture. So it is started in 2014 and gives guidelines to construct the industrial internet system. And it is clearly shown here that IIRA states the 5-layer system. Then the business layer, then application layer, then information layer, then operation layer, and finally the control layer. In the business layer, they provides the function to allow end-to-end industrial operations such as work planning, the scheduling, enterprising resources planning, means ERP, life cycle management. And in the application layer, it's allow the execution of some tasks or goal by implementing the actual application logic, such as the application programming interface, user interface. Those are the example of application layer. After the application layer, there is a information layer, and in the information layers are used to collect the stored data, syntamics, transforming the analyzing data providing, and finally deployment. And there, after that, the operation layers are responsible to operate properly during the life cycles. It also responsible for asset deployment, configuration, and update, diagonization. Those are they are responsible. And finally, the control layer. In control layer, the control layer is responsible for control of industrial assets such as sensor, actuator, and the communication devices. This is the control layer, and this is the last layer of IIRA, a 5-layer system. Second architecture is RAMI 4.0. So RAMI 4.0 is the 3-dimensional 6-layer architecture shown here. This is a 6-layer architecture which is proposed for industries 4.0 and provide the service oriented. This is known as SOA. This is the service oriented architecture. SOA full form is service oriented architecture for to assist and simulate the main characteristics of industry 4.0. The main focus of 4.0 is main focus of this RAMI 4.0 is SOA. That means the service oriented architecture. After that, the one-to-one. After that, the one M2M. Okay, the main element of M2M architecture is shown over here, and the M1 M2M, it was formed in 2012, very recent in 2012, and it is initiative the 8-layer ICT standard organization. 8 ICT standard organization recognize it. I think that is the ETSI, the European Telecommunication Standard Institute, and the Association of Radio Industries Business, ARIB, the China Communication Standard Organization. Like this is like the 8 standard organizations has developed this M2M, and the main goal of M2M is to define the horizontal service layer to provide a way to connect and communicate with different IoT system. And last one is the Arrowhead framework. An Arrowhead framework, this is standardized by EU, means European organizations. Okay, and the EU Arrowhead project it is started after the previous one is 2001, M2M in 2012, and after 1 year, this Arrow framework is introduced in 2013. And this proposed architecture is described to the workflow of IoT-based automation. This is described by IoT-based. You just notice that there is several sensors there: sensor B, sensor C, and the system SMI. So this is the sensor-based system, and this describes the workflow of IoT-based automation. The automation is the main part. The previous one was the SOA-based system, and this is the automation-based system. And the proposed architecture is open source framework, is according to the guideline of RAMI 4.0, and the project are already underway to contest the successful prediction by this Arrowhead framework. So all the architecture proposed for IIoT for mining industry towards the industry 4.0, we are talking about the digitalization of the industry. We are talking about the automation of the industry. That's why recently we have collaborate with the our university sign a MOU with ISCO Burnpur. So they are also looking for digitalization of the cell industry. So based on this 4.0 digitalization of the industry 4.0 revolution, this type of this type of IoT architecture has been proposed. Now the vertical slice of each domain of mining. There is the cloud, interface, and asset domain. You just notice that the cloud, in a cloud there is a this system and application are not able to interfere, and these commercial system have their individual technologies stack and data formats. Hence one system and incorporate with another a system to of the same provide, but unable to incorporate with a different provider. The cause is that the big burden for applying the industrial internet paradigms in the mining industry, and for the slow production. And this is the main problem. And the mining industry facing the various challenges, which we will discuss later. The technological varieties, processing of data, the data distribution, security, data management, those challenges are taken care of mining industry. We will discuss individual challenges later on. So this is the key challenges for implementation of IIoT in the mining industry. Number one is the technological variety. That the development of IIoT, those are the challenges. We have to overcome those challenges for for deployment of IIoT devices mines. Number one is technological variety. The development of IIoT based system is based on 5 main technologies. Number one is wireless sensor network. We are working on that. Number two is radio frequency identification, cloud computing, middle way gateways, the IIoT application softwares. Moreover, the various technologies, technologies based on different set of technologies. Those technologies varieties adopting in mining industry is difficult. Number two is processing of data. The matter of data processing is processing or ownership of data is important challenges, not only in the mining industry but across the other industries. The data processing, who is the owner of this data, who will give the data for research. This data processing is the another challenge. The database distribution, between the legacy systems in the mining industry, the data is distributed across the different legacy platform system and causing the problems to gather the information for analytics and further operations. This is the another challenge. Then security also another challenge, and data management, and finally the analytics. So analytics, those are the key challenges in mining industry. Now the IIoT architecture in mining industry, we have already discussed the 4 types of architecture. This is the IIRA, RAMI 4.0, 1M2M, and Arrowhead framework. What are the key considerations? For IIRA, the viewpoints to investigate into the mining industry, and for IIRA is the functional domains to categorize the domain in mining industry, and IIRA is consulting functions necessary for the mining industry. Those are the key consideration. For RAMI 4.0, we already told that RAMI 4.0 is the 6-layer structure, and investigate into the mining industry layered architecture approach, the cross-cutting functions necessary for mining industry, the administration cell of RAMI 4.0 to categorize control and operation domain, and 1M2M, and the 1M2M common service entity as information domain, and the data management and reciprocatory information domain, the group management. Those are the problem, and finally the Arrowhead. Those are already discussed in previous sections. And now the synchronization IIoT architecture in mining industry, and there is a synchronized IIoT architecture in mining industry. There is several sectors there. Number one is edge control domain. Number two is edge operation domain, information domain, analytics domain. Finally, the business application domain and cross-cutting functions. We have to at first we will discuss the edge control domain. The edge control domain is mine site, consists of various component as OT. I already told OT plus IT equals to IIT. That OT software, operation technology software, IT softwares, that sensors, actuators, device, and other physical system related. The edge control domain is related to the physical system. So this domain responsible for various functions that are carried out by the industrial control and automation system. And number two is the edge operation domain. Edge operation domain, the edge operation domain is nothing different type of such as surface and underground mines. There is an operational domain can be inside the mine or the surface start of the mine. In case of underground mine, the operational domain is responsible for management of operation and control domain. The function of domain is charge providing the deployment asset management, monitoring and diagnosis, optimization. Those are the issues can be taken care by the edge operation domain. And number after that, the information domain. Information domain nothing but a in the information domain nothing but a information information domain nothing but a managing or processing of data information. Okay, and the most domain acts as an information hub with the functions for gathering data from various domains, and most importantly from the control and operations can reside on site and off site or cloud. We can gather, we can store this information locally in local server, or we can store this information in the cloud. So this is related to the information domain. In analytics domain, we'll discuss we'll discuss this information domain mainly from the analytics repository or processing of those data. After that, the business application domain. That business and application area is technical environment for execution, the practical expertise or the application logic that is important. And finally, the cross-cutting function, the various domain described above focuses on major system functions that are generally required to support the IoT implementation. So this synchronized IoT architecture can overcome those challenges we have discussed previously. Now, the edge control domain we have already discussed. The edge control operations we have already discussed. Edge control domain, OT software, IT software, sensor, actuator, devices. The edge operation domain, those part we have already discussed. The operation domain is responsible for management of operation of control domain. Function is this domain is the charge of provisioning and deployment, asset management, monitoring, diagnosis, optimization. And finally, the information domain, the processing of information. This information can be hosted locally or on site. That we have already discussed. Analytics domain get data from information mainly from the analytics repository or from analytics. Similar information domain, it can be also decide on site or off site. And this is already discussed with the slide. The business and applications area is a technical environment for execution of practical enterprise and application logic. The reflect business functions that help the business processes and business functions of administrative tasks. The IoT framework will be the implement to facilitate end-to-end operations. And these are the cross-cutting functions. There is a two type of cross-cutting function: distributed data management and the safety, security, reliability, privacy, and resilience. Those are the main those theta connectivity and interoperability. Those are the main characteristics of cross-cutting functions. And the reflections, the few research efforts tried to solve specific problems by IoT in mining industry, such as ventilation monitoring, accident analysis, fleet. This is already we have discussed. And however, it can be overcome by IoT and IIoT devices. And open research areas and directions for the researcher who want to work on this particular domain. There is an open directions. We can work on interoperability and intergram, scalability, flexibility, security and safety, mobility management, centralized and distributed system of management, virtualization of edge, and digital twin. Those are the open research direction and challenges. And this is the summary. The IIoT is the source and enabler the industrial automation that opens possibilities for important insight applications in several business areas. Together with this operational technology and information technology converge together to get the solution. Now the acknowledgement. We have to acknowledge our funding agency. We have got some project related to this digitalization in IoT-based sensor design, in underground mines. We have got project from UGC Stride. We have got project from Department of Science and Technology in association with the Asian secretaries. Those are the acknowledgement part of my talk. And finally, thanks for the comprehension. Thanks for your support and thanks for inviting me. Now it's open for the question session.
Thank you. Thank you, Professor Vishwas. It was a very good lecture on IoT. Students have enjoyed it. Most of the participants, I think, have enjoyed it very much. Our next lecturer will be Professor Joydev Dotto. Professor Joydev Dotto is working as assistant professor at
Excuse me,
Kazi Nazrul University.
Ranodeep, excuse me, myself.
Hello, yes, sir.
Myself, Joydeep Dotto, not Joydev.
Yes, Joydev Dotto. That was I'm
Yeah, yeah,
telling.
yeah.
He is working as assistant professor at Kazi Nazrul University. He is in computer science department, but he has a lot of publication in, I think, mining optimization and in algorithm and also in sensors. He is working with a lot of us. He is a well-known faculty. So I request him to kindly share your words, sir. Sir, it is up to you. Thank you, sir.
Thank you, Ranodeep, for your nice introduction. And firstly, I would like to pay my gratitude and respect to all the eminent personalities present here, especially Chairman Sir, Durgapur Local Chapter, and definitely our Sir, Evergreen Sir, Professor Nitai Chandra De. I used to take the energy from him. The way he has given his lecture, it was really nice. From the very beginning to last, there is no limitation. There is no limitation of energy. Continuously, he was speaking. So I learned so many things from you, and I would like to reflect in my lecture also from you only. And definitely, all the students, those who are present here, and all the eminent persons. So I'm going to start my talk. I'm just sharing. Ranodeep, are you getting the screen?
Yes, it is visible.
Okay, just a minute.
Please take your time, sir.
Is it coming, Ranodeep?
Yes, it is coming. Yes,
Okay.
it's fine now.
Okay. So today's topic is computer applications in mining. So definitely, as all the speakers have already told, that we cannot imagine any domain nowadays without computer. As we are here, it is because of the computer and its latest technologies. Now the platform is Zoom. We are using Zoom. That is also the application of computer only. And all the persons who are related here, basically from mining industry. So from the very beginning, here also we can start. It is an application of computer that we are here. And now I would like to start my presentation. First, I would like to say, what is mining? Mining is basically extraction of valuable minerals or other geological, just a minute, geological materials from the earth, and usually from an ore body, lode, vein, seam, reef, or placer deposits. Exploitation based on the economic viability of investing in the equipment, labor, and energy required to extract, refine, and transport the material found at the mining to manufacturer who can use the material. So basically, this mining is going to start from the extraction and it goes up to the delivery of the products to the last part. So total thing involves this mining. Now we have to know what are the places where we can apply computer. Firstly, there are so many areas in mining we can apply computer, especially surveying machines, conveyor belt, GPS system. In surveyor machine, the surveyor machines are connected to laptops to get 3D views of the distributed geology around a place. Computers are also used in controlling the conveyor belt nowadays. And even we can use GPS system to track about each and everything that we want to track. And one more thing, that operational data is a huge data. To control those data, to preserve those data, and to get some analytics, to get some pattern from those data, we need the help of storage in computer. Now, what I would like to suggest, computer application in mining, rather we should say digitalization in mining, because digitalization in mining is basically the greater term compared to computer application in mining. Now, what is digitalization in mining? It refers to the use of computerized or digital devices or systems and digitalized data that are to reduce cost, improve business productivity, and transform mining practices. It remains increasingly difficult for mining companies to decide which digital technologies are most relevant in their needs and individual mines. Now here I would like to say one thing. Nowadays there is no area where we can apply, there is in every area we can apply the computer, definitely, but especially in mining we have to take care so lot of things, that whether which technology should I use or which technology we should not use, because there are so many constraints in mining. Now it is really a research where we have to go, because a lot of things we have to consider. Now digitalization in mining can have so many equal terms like fourth industrial revolution, digital revolution, digital transformation, intelligent mining, smart mining, mining 4.2, 4.0. So basically there is a slight difference between each and every term, but if we say on an average, all are going to define the same concept. That is basically the utilization of computer and its latest technologies in the domain of mining. Now, as per the concept of definition, digitalization originally refers to the continuous evaluation and change of particular processes and procedures based on digital technologies. So there is no limit here. It is a digital technologies. It can be anything that we can impose in mining and we can get benefit from that. So that can becomes under digitalization. And what is digital transformation? It is basically, we can say, the output changes. Because of digitalization, what are the changes we will do? That is basically digital transformation. So actually, because of digitalization, the digital transformation will happen. And there are some other terms are also, that is intelligent mining, smart mining, mining 4.0. So basically these limit the digital transformation to mining industry. Basically, it is basically a particular part of the digital transformation that is involved in mining industry. Those are called intelligent mining, smart mining, or mining 4.0. Now here I would like to show what are the latest technologies that are mostly used in the mining domain. So this document identifies the digital technologies relevant to mining operations of different production scales from the low to high. Now on the topmost we can see it is the automation, then big data, Internet of Things, robotics, real-time data, 3D printing, artificial intelligence, drones, machine learning, data analytics. So if you see, all these terms are coming from the root, that is computer. So I can say these all are applications of computer. So these all things we can apply in mining, and this graph is going to show how and which technology of computer is going to use in mining in which percentage. That is, here we can see the automation percentage of use is 80%. Big data percentage of use is 60%. So like that, this is the hierarchy of uses of different computer technology in, especially in mining. Now, this is basically a network structure of all the technologies of that roots from the computer and that has been used in mining. And we can see the size of circles. The more circle, the bigger circle is, the bigger application in mining is there. The first and final is automation. You can see just now in the previous slide, we told number one is automation, 80% coverage. So that is why this is the biggest circle. Then machine learning, artificial intelligence, 3D printing, robotics, Internet of Things, digital twin, and real-time data. So many things are there. These all are technologies that we have already applied. We the researchers have applied in mining domain. Now, here I would like to explain little bit, so a few of those technologies. First and foremost is automation and robotics. What is the purpose? Basically, the purpose starts from decoupling of human from technical machineries. So actually in mining, the environment is very hazardous. So always we try to reduce the number of persons involved on those risky areas with the help of robotics and automation. That was the main purpose. So robotics deals with the development and uses of robots, whereas automation defines the operation of existing machines and unattended processes without human control. So we have tried with the help of automation and robotics to reduce the manpower, and by the machine we can do all those things. So uses of automation is basically in the processing steps. So in mining also, there are so many areas of the processing steps are there. There we can apply this automation. Now, some examples, especially surface mines use automated trucks. So automated trucks can be used in the processing steps in mines with the help of this automation and robotics, that can reduce the manpower involved in those areas. As well as we have also find that automated loading is very difficult. That is why the lack of automated loading practices is likely due to changing rock conditions and material position at individual mine site. So actually in each and every mines, there are different types of rock scenario. There are different types of environment is there. So it is very difficult to implement this kind of automated loading. That is why we have seen this automated loading percentages application is very rare. Now, Internet of Things, as our earlier speaker, Dr. Arindam Biswas has told so many things regarding Internet of Things. So I think I no need to say a lot of things about Internet of Things, but still I'm going to say the basic definition of IoT. IoT is an approach whereby physical objects are interconnected and able to communicate their status over the internet and be controlled remotely from any position. So it is really a great advantage, and we can think with the help of this Internet of Things, the whole world is going to change in the upcoming 10 or 15 years. So everything will be controlled. With the help of on a single click on mobile, we can control a lot of things. So that same thing can be applied in mining also. Some of the uses are track the position and loading status of trucks, which helps to coordinate the mobile equipment, track people of emergency situations, monitor rock stability and movement in underground mines, connect to low-cost sensors to deliver data to a central point, and to act as a cross-platform system. So, etc. There is no end if we go to describe the application of IoT. Now, next technology of computer science is big data and real-time data. So nowadays, big data terms is totally mostly used jargon in the computer science technology. Big data, what is big data? Big data means a huge amount of data that cannot be handled by conventional data processing or human competencies. So we need some sort of expert system. We need some sort of expert machines that can handle those big data. There are different softwares are used to handle those. There are different architectures like Hadoop architectures are also there in the market to handle this big data. The term real-time data relates to the speed, responsiveness, and timeliness of delivering the data to the user. Nowadays, it is the age of competition, fast. The company who is giving the fastest service is getting the fastest order. So So these two terms, big data and real-time data, are very essential. Uses predictive maintenance systems for belt conveyor or dump trucks rely on big data and real-time infrastructures. Mass flow simulations and visualization of block caving activities to understand and monitor the actual mining void. Time critical atmosphere monitoring systems. So a lot of applications are there. Next is artificial intelligence and machine learning. This is also a most emerging technologies. It is already in the market for last 15 years. It was artificial intelligence, and nowadays the topic is machine learning. These are booming technologies. If we see the research papers, we can find almost in each and every domain this machine learning is involved. So basically, what is this? First of all, we should know what is learning. Learning is with the experience. Our output will be better. Basically, what is learning? Learning means our output should be improved based on experience. Then and only we can say a machine can learn. So machine learning is commonly perceived as a subcategory of artificial intelligence. Then what is artificial intelligence? Artificial intelligence is basically a subject or a paper, we can say, that involves how to do things presently man can do better with the help of a machine. That means we have to develop intelligent machine so that it can react like expert human. So intelligence are of two types, we can say, human intelligence and artificial intelligence. All of we know what is human intelligence. So all the human intelligence is going to replicate it with the help of artificial intelligence. So basically we can say that robotics, machine learning, all these are part of artificial intelligence. Basically, this is a superset. Now, uses, definitely, if I'm going to say about artificial intelligence, I should say one more term, that is expert system. Expert system is basically the product of artificial intelligence. It can also be developed in any domain. Even in mining also, we can develop some expert system. Now, one example of expert system I'm going to tell here, that is mycin. Mycin is applied on medical domain. What it will do, it will take the symptoms from the patients and it will predict what therapy the patient should do. But how they are going to predict? Because in computer, it is right. Computer has no brain. Whatever we will supply, it will do based on that only. So definitely in expert system is also, we can say, one kind of special type of software system where we take the input from lakhs of doctors. If this happen, what will do? If this happen, what will do? Like that, there are thousands and crores of rules will be there that will be imposed in expert system. Similarly, we can also create expert system in mining domain also. We have to accumulate all the different scenario, all the if and else relationship. If this happen, what should we do? If the sensor output is this, then what should I do? Like that, all the rules we should accumulate, and we can capture, after capturing those things with the help of knowledge engineers. What are knowledge engineers? We know all software engineers. The engineers who develop software, they are called software engineers. But the engineers who are involved in building the artificial intelligence product expert system, they are called knowledge engineers. So by accumulation of all the rules of mining, if we use the knowledge engineers, they can build the expert system dedicatedly for mining industry also. So this is an application of artificial intelligence. Now, some other uses are also there. Structured data from infrared spectroscopy or images from drone are processed by machine learning algorithms to determine the mineralogy of exposed lithologies in mining areas. Mining operations use historical data together with ML techniques to reduce the breakage and fly rock phenomena in blasting operations. So there is a huge scope is there, but only thing we have to know the particular which technique we should apply in which sector. Next is 3D printing. 3D printing is a process that creates 3D items from digital 3D models. The item are produced by sequential layers of synthetic, and metallic materials. Uses produce spare parts and custom built components, which in turn can reduce the cost of storage, production, and delivery times. It is possible to use geological data, pictures of drones, or point clouds from laser scanners to create digital items and print those 3D ore deposit or open pit model for illustrative purpose. So with the help of this 3D printing, it is very easy for us to teach our students also, because sometimes it is very difficult to show the actual scenario to the students before they are going to expert in that domain. So with the help of this 3D printing, we can utilize in case of our instruction, in case of our teaching learning process also. So like that, there are a lot of scopes are there for 3D printing. And here I'm going to list some of the real-time implementations of the application of computers. In 2014, the one gold mines in Canada installed IoT systems monitoring system, which included sensors with wireless network for real-time tracking and control of equipments and underground processes. These technologies also allowed implementing the ventilation on demand system, which reduces the energy cost by more than $2 million per year. Another examples is also mentioned here. So like that, there are a lot of implementations are there. One more example is geology and mining system, GMS. That is also a very good application of computer. It is a computer aided valuation system. It can be used in many areas like survey, stratigraphy, assay database, drill hole, bench compositing, 2D and 3D log sectioning, contouring, 3D surface generation, cross sectioning, 3D ore body modeling, designing of open pit, volume and reserve estimation, economical valuation, etc., etc. This GMS is applied in evaluation of magnesite ore body in Turkey also. It is already implemented in Turkey. Now, there are a lot of mine planning softwares are also available. Modern mine planning software play a crucial role in the operation of many of the world mining operations. There are a number of software products already in the market that cover a lot of ranges of capabilities of mining. For example, Vulcan from Maptech Fly Private Limited provide the necessary CAD functionality as well as 3D visualization. Normally, the standard functionality carried out by any mining software, these are visualization, modeling, database management, reserve calculation, mining design, mine planning. And in conclusion, or should I say that larger mining operations or any big organizations can apply many more digital technologies based on their need. But it has been observed that in lower production sectors, it is not so easy to apply digital or hardware technologies because they don't have that much of fund. So it is very difficult to choose which technology they will apply. So in case of minor producers, it is required that digital transformation solutions should be tailored to their capability. All the capabilities may not be required for those organizations. So based on only their demand, we should prepare some tailor-made software so that they can use and they can utilize it and they can make progress in their life cycle. So here I have attempted to show some of the applications or some of the technologies of computer science to apply in mining only. So practically it is an ocean. Actually, computer science is not a standalone area or standalone, I can say, engineering. Rather, we can say it is a set of tools that we can use in any domain. It can be mechanical, it can be civil, it can be mining. So we have a lot of tools ready for you. So you just choose which tool you want to apply based on your need, and you just apply it and you will get benefit from that tool. So this is a small attempt from my end. Thank you. These are the references I have used. Thank you for the patience. Thank you.
Thank you, sir. It was a very good lecture. We have learned different applications of computer in various forms like AI, machine learning, automation, big data, and other applications. Thank you, sir, for your valuable lectures. Our next speaker is Mr. Ali Murtuza Sheikh. He is working as deputy manager as Coal India Limited, and he has also completed his first class certificate. He has an experience over 7 or 8 years in working in underground coal mines. So I request Mr. Ali Murtaza Sheikh to please share your slides and valuable lectures, please. Mr. Ali,
I think,
please.
sir, someone is sharing his screen, so he should be stopped.
Just a minute, I'm trying to stop.
Good evening, everyone. I would like to thank IEI Durgapur Local Center for organizing such a recent demanding topic, that is computer application in mining. And being the last speaker, nothing is being left because all the expert speaker have already been discussed in different fields, like Professor MC Desar has been discussed over the ergonomics with the help of computer applications, IIoT, and others related topic is being discussed by Biswas sir and Joydeep Datta sir. So in the same line, I would like to add more some topics or points. So I'm sharing my screen. Is it visible, sir? Ranajit sir?
Okay.
Yes, it is visible.
Okay. Let's start. Computer application in mining. Being directly involved in the mining industry, I will discuss some topics or some points rather, which is being already discussed, maybe overlap or may not be. But during the previous stages where the mining operations has been started, at that point, computer is not being available, but at the time mining operations is also being continued. But during the development of computer or digital platform, there are several sectors that incorporated the digital platform to increase their production and productivity, and including the profitability. At the same time, mining sectors also incorporated in different fields, different activities, the utilization of mining, utilization of computer or a digital platform to increase the production and productivity in different aspects. Though in not up to that mark, the utilization or applications is being done, but in several activities is carried out with the help of computer or with the help of different types of softwares. So being industry professional, I would discuss all those things. What are the scopes where the computer is being applied in the mining sector, and what are the areas which is being not even touched and not is being applied the computer, and all the future scopes where the computer applications can be done. All those things I will discuss in brief. Mining is, in simple words, it is the extraction of valuable minerals or other geological materials from the earth, usually in a different form, like different ore body in the form of lode, vein, seam, or placer deposit. To extract all those minerals, there are several activities. They may be in parallel or maybe in series. To complete all those activities, we require some manual work or may require with the help of other alternative ways. So if same work can be done manually or maybe available alternative way which requires less manpower, less cost, less time, so why should I not use all those alternative ways? That's why the computer applications comes up. So computer applications are what are the scopes? Computer applications means enabling people to use it as a tool to complete or finish a specific task easily with shorter period of time. So this is the computer applications. For example, word processing or word making, data processing. It may be in the form for the manufacturing, for the production, or data related to employees who are working in a particular mine or particular unit, maybe in the form of spreadsheets, communication purposes, or maybe in the form of software used for different types of purposes or activity. So all these are the computer applications or in all the fields that there can be computer can be applied for the better efficiency. So why we use computers in mining? It saves lots of time. The same work or same activity that can be done manually. For example, if a planning for a particular block, mine planning for a particular block, if we do manually, then there are several persons to be engaged and there are several activities to be done if we not use any mining, if we not use any digital platform or computer. So that will take much more time. That will be that will require much leverage job. That will require much manpower. And if we use alternative way, that is the digital platform or computers, where it will give us benefits like it will save time, save energy, less manpower will be required, and for the same job, this comfort will be provided for the man who will just sitting in a computer room will do the activity and the same activity, and it will be also the cost effective and will minimize cost obviously. So that's why we use computers in mining sector or in mining industry. In the 12th National Safety Conference that was held in January 2020, several aspects has been discussed into that 12th National Safety Conference, where one aspect was discussed or about the role of IT in mining sector, where several recommendations has been given for the implementation into the mining sectors, like digitization of initial medical examination, periodic medical examination, vocational training, and it must be linked with other. This is a recommendation from the 12th National Safety Conference. Digitalization of the employees register, the employees details which has been noted down in the form A in pen and paper, but the recommendation is being given to store all those information in a digital platform, that is digitization is to be made. Smart digital token for employees with employees details. Like we see in our daily basis, a smart card in different fields where there is a barcode, and as and when we scan it, the details information is shown on the computer screen or in the mobile screen. That type of digital token to be provided and to be incorporated for the employees working in a particular mine or in an area. Next one is biometric attendance system based on Aadhaar card. This is being already implemented in different units or different subsidiaries with the linking with Aadhaar number or Aadhaar card. Biometric attendance system has already been implemented. Machine digital reference number for all machinery. Where the machinery is being used, there must be given a digital reference number, and with the digital reference number, digital tracking of all those machineries is to be seen on the computer screen in real-time basis. Where the machinery is working, where the machinery is placed on real-time basis, it can be monitored or can be tracked and at any time. Digitization of plans, sections, or records. All those plans and sections, what are being done in manually in tracing paper, and all those plans and sections are being made by surveyors or Department of Survey for a particular colliery or particular mines. All those things is to be made in a digital platform with the help of computer. This is the recommendation of 12th City National Conference. And the next recommendations was digital platform for rescue apparatus equipments, trend and manpower availability. What are the apparatus available and what are the rescue tent persons, what name of the rescue tent persons, all those information is to be gathered and stored in a digital platform. So these recommendations given by the 12th National Safety Conference in 2020. So all those things is to be implemented in particular colliery mines or units. Computer use or applications where we use, or what are the scopes where we use computer or digital platform for geotechnical information, storing or processing the geotechnical information, reserve estimation or reserve calculation, reserve estimation calculation, geological modeling, mine design, designing of any particular mine, maybe underground or open cast, pit optimizations or the pit limit, dump design for open cast working method. Overburden is to be dumped in a particular places. So what should be the angle to prevent the failure or the stability of the slopes? So dump designing is to be done, equipment selection and scheduling. So all those things is to be required with a particular with the help of software and by the use of computer. Blasting optimizations to get maximum efficiency or fragmentations, we require some type of digital platform to optimize the blasting efficiency or blasting product. Optimization of ventilation circuits to get maximum efficiency in the ventilation, or in the ventilation circuit, we require some type of software or computer-based digital platform. So there are some softwares which are used widely, not only in India, also all over the world, like GeoVia-Minex. GeoVia-Minex is the recognized as a geological modeling and mine planning solution for stratified deposit mainly. Stratified deposit means coal, limestone, or bauxite, this type of deposit which are being deposited in a stratified layer that are called stratified deposits. To planning all these type of deposits or minerals, GeoVia-Minex is used. Minex also ensures resource evaluation accurately and mine efficiently from the exploration to the rehabilitation point. So throughout the stages, all the planning is being done through GeoVia-Minex for the stratified deposits. GeoVia-Surfac. GeoVia-Surfac is the world's most popular geology and mine planning software. This software is being used all over the world, around 120 countries, for open pit, underground, as well as for the exploration purposes, for planning purposes. This software is mainly used for modeling and planning of non-stratified deposits like metal mines. So GeoVia-Surfac is mainly used for metal mines and non-stratified deposits. Benzene, this is another important software which is being used in underground mine ventilation simulation. For underground mine ventilation, there are lots of problem faces for different Indian mine scenario. So to get rid of all those problems or challenges, Benzene is a good solution. This packages includes designing model and simulate ventilation, airflows, pressure, heat, gases, fire, and many other type of ventilation related information. So all these informations can be modeled and simulated through Benzene software with the help of computer. Vital, this is another software, and this gives the trusted results for scoping, feasibility, life of mine scheduling, and the ongoing re-evaluation of the mine plans throughout the production phases. So throughout the production phases, with the help of the softwares, scoping, feasibility, and scheduling can be done. 3D pit optimization is also being done based on the latest Grossman algorithm with the help of this Vital software by using the computer. Blast IQ, this is another software is being used for the optimization of blast designing, which gives the better result for blast outcomes and fragmentations, and indirectly which reduces the costs. Centralized blast information management, which is with the help of this blast IQ software, which views, shares, and analyze blast information anywhere at any time. So this software is very much important for blast designing and get effective and high quality blast outputs or fragmentations. Enterprise Resource Planning or ERP. ERP is the integrated management of main business processes, often in real-time basis. With the help of software and technology, this integrated management system of different business processes can be done or is being done. ERP is usually referred to as a category of business management software. Typically, it suits for the integrated applications. The organizations which collect, store, manage, and interpret data for many different activities. Like for the mining operations, we extract coals by drilling, blasting, loading, and transporting materials to the surface. So all those data are collected, how much holes is being done, what time is required for drilling all those holes, how much amount of explosive is being blasted, how much coal is being transported, how much time is required. All those information is gathered, stored, and managed, then interpret this data and get a result for the real-time basis analysis. ERP systems can be local-based or cloud-based. The cloud-based applications have grown in the recent years due to the information being readily available with the help of internet access from anywhere around the world and around the country. For the particular organizations, everyone can access through the internet and at any time. Recently, Coal India Limited introduced ERP by SAP SE for the analysis, real-time basis analysis of the production, manufacturing, utilization of different parts, machineries, all those things. Communication and monitoring purposes. For communication from the surface to underground, we have in the unit level controlling room or CDS room from where the communications is being done from surface to underground or from surface to surface, like conveyor belt and any other transport monitoring through a computer-based digital platform. A person sitting in a room monitor the conveyor belt or any other transport vehicle. RFID radio frequency identification or GPS-based monitoring, which is being done for the trucks, dumpers, or other machineries on real-time basis, where the machinery is present, where the machinery is working, where under operations or where it is moving. All those informations is being obtained by sitting in a computer room with the help of RFID or GPS tag systems. Further applications which required in the field of mining, that is maybe with the help of nano or micro technology, and maybe in some extent with the help of electronics. Also, drilling operations monitoring by computer screens, where the drilling operations is being done either surface open cast or in underground mining method. When the drilling operations is being done, the drilling rig in some extent deviated from its desired point or desired directions. So if there is something can be monitored in the top of the beat, if there is some arrangements for observing or monitoring the direction by the operator or any other persons sitting in a computer screen, for that purposes, the deviations can be prevented or can be rectified. One is monitoring of highly mechanized mining machinery like a continuous miner machine or longer mining machines. The cutting directions also get deviated due to several reasons, like the dust accumulations or the unsupported phases, visibility from far distances. So accurate observations cannot be possible. So in that cases, if there is something arrangements for camera system or computer-based some technology where a persons can be monitored, a persons easily monitor the machines in which directions it is cutting in a real-time basis, in which directions the phase is going on, that can be monitored by sitting in a place. For geological disturbance, advanced indicator system for drilling operations as well as for coal cutting or coal extracting operations. If there is something, any indication system that can be developed in a computer-based or a digital platform, so it will help the mining industry it will be very much useful for the mining industry, and to prevent if there is any disturbance, geological disturbance, that can be rectified, that can be avoided with the help of such advanced indications. So thank you for tolerating me for these few minutes. Thank you everyone for giving your valuable times.
Thank you, Mr. Ali Murtaja. Thank you very much for your valuable feedback and lecture. Thank you very much. So with this, we can end our lecture. But whenever I found an opportunity to attend such type of lectures, I always found that my knowledge increases, and it is a highly enriched presentation by all of our eminent speakers. I must thank all of them. Whether it is coincident or not, we started by human and machine interaction. Professor Day, as told by him during an ergonomic study. And then we moved to IoT, separate human and machine, as told by Professor Vishwas. And after that, the decision that was taken by the human was replaced by artificial intelligence, machine learning, and other algorithm that was described by Joydeep Dotto. And lastly, Ali Murtaja has finally described how to plan with this computer application like Sarpac, Minex, and other different computer application softwares. So it was a complete cycle, I think. So it was very good interactive sessions. I thank all of you. With this, I hand over to our secretary, Manus Mujumdar. Sir, please express your words. Thank you. Thank you all. Sir, Manus Mujumdar, sir.
It is my immense pleasure to give vote of thanks in today's seminar on webinar platform.
Your voice is not audible, I think.
Voice is not audible. Yeah, am I audible?
Yes, sir.
Are you okay? It is my immense pleasure to give vote of thanks in today's seminar on webinar platform. As we covered a very good webinar, the speaker told today, which is very helpful to us and the mining persons all through the industry. First, I thank Dr. G. Ranganath, Chairman Kate, who told some useful speech. Thanks to Dr. Ranganath. I thank Dr. Hemant Thakare, President IAI, though for his busy schedule, he is not attending the webinar, but we received his advice and hope we will get his support for conducting such type of seminars in future. Dr. N.C. De, eminent speaker, chairman, MNDB, and Department of Mining Engineering, IIEST Sipur, told some very useful speech on ergonomics and which is the right posture for a workman in any industry. Thanks, Ranadip Bhattacharya, for his useful speech and organized today's webinar. I thank Dr. Arindam Biswas, Associate Professor and Head Department of Mining Engineering, Head Additional Charges, Department of Computer Science, Kaji Nazrul University, Asansol, for his speech regarding IoT in mining industry and IT in this industry. Thank you, Dr. Joydeep Datto, Associate Professor, Assistant Professor, Department of Computer Science, Kaji Nazrul University, Asansol, for his very valuable presentation regarding mining and place in computer in mining. I thank Mr. Ali Murtaza Sheikh, Deputy Manager Mining, Coal India Limited, for his valuable experience in working in deep mines and computer application in mines. I thank Mr. Manoj Kumar Biswal, immediate first chairman, past honorary secretary and technical officer, CSIR, CMEIR, for his cooperation despite his busy schedule. Special thanks to all the technical team of IEI headquarters for the great support in organizing the seminar through webinar platform. Lastly, I thank everybody who were attending today's seminar on webinar platform. Thanks again. Thanks again, everybody. Good night.
Thank you all. Hello, sir. Good night.
Thank you. Good night. We are ending now.
Good night.
Thank you.
Good night.
Good night, sir.
Good night.
Good night.